Okay, so now I'm going to show you how to plot a growth curve on a semi-log paper using optical density data and also using Excel. And also show you how to do the colony forming units per mil data from the plate count. So the data we have is from here. So this is the data. And I'll show you the semi-log paper first. So semi-log paper has the linear axis in one direction. This one is in semi-logarithmic, so that's why they are not even. So this is a 4 cycle, therefore there's 1, 2, 3, 4. So how you would label it is you decide which one is your first, and that's dependent on your data. Since our data is about 0.02, is the lowest OD value, so I will set as 0.01. So you do not start with 0, unlike the linear, the logarithmic starts with 0.1 or 0.1. So this would be 0.01, and this will be 0.02, 0.03, 0.04, so on, all the way to 0.09 and 0.1. Now it will not be 0.11, but the next cycle would be 0.2, 0.3, 0.4, all the way it's going to be too squished up to draw, so the 0.9 and it will be 1. Then it'll be 2, 3, 4, all the way to 9 and 10. The next cycle will be 20, 30, and you get an idea. So it'll be all the way to 100, and then it'll be 200, 300. So every time it'll be 10-fold more. Okay, so but this one is time on x-axis, optical density, or you can also put the CFU per mil on the other side to use the same graph paper to plot the data. So I already plotted here using the data that we have. This one is that at 30 minutes, it was 0.019, so it's almost close to 0.1, 0.02, and then the 60-minute was 0.035, so that's how these are plotted. I don't know if you can see it clearly, but I'll show you later too. So it started to look like that, so all the way to 300 minutes. So you can see sort of a going logarithmic phase. We already missed the lag phase. Lag phase probably happened around the first 30 minutes. It's already started to pick up and then hit the plateau around 270 minutes. It started to taper off. It's not going to be sharp edge line. So the key thing is you have to find the line that best fits like a logarithmic phase. So you basically take a ruler and see which line, draw a line that connects, well, not connect, but goes through most of the dot, which we call the best fit line, right, curve. So yeah, you will not get every line, a dot touching the line. Some will be off, and that's perfectly fine. You don't need to include the plateau one. And then you want to find the main purpose of doing this is to find the generation time. So what you do is find two OD values that are double. One is the double of the first number. So if you pick 0.1, the next one you have to pick 0.2. Or if you picked 0.3, the next one has to be 0.6. which is here. So just pick any two number, one number and then the double of that. And it has to fall in this range in the logarithmic phase, not outside of the log phase. So if I pick 0.1, then draw a line to connect to the slope that you just made, and then bring it down where it intersects, then bring down vertically. And then the next double OD is here. Instead of pick 0.1, you have to pick 0.2, the next number. So how long did it take to double the optical density is what we are looking at. So this time interval is the generation time. According to this, it looks exactly 30 minutes. So it could be 35, it could be 40, it depends on the slope. How inclined it is will dictate how long it takes. Now there's another way of doing this too in the absence of graph paper. So you do want to try both of them. You can also use Excel to do that. So let's try that. So this is the data you have, which you will be, which you're given, or another version of this data. So I'll show you how to plot the optical density, and then we'll use the CFU per mil. So this needs to be done in logarithmic scale, not the linear graph. So Excel will first plot it in linear, then you tell it to plot in the logarithmic scale. So these are the two you want to pick. Insert chart, make sure you pick the scatter plot. Now, once you get this, this is in the linear, so you want to tell Excel to make this y-axis logarithmic. So make a right click, format axis, and then you select logarithmic scale. You can also put your maximum and minimum 0.01 to 3. That sounds about right. If it's outside of the range, you can change that. I'm gonna put the tick marks too. You can do major, maybe outside. And if you want minor, you can do minor too. And you can tell it to connect those major minor lines as well. And then it looks like somehow it made this x-axis label, horizontal label right in the middle, it moved. So it does that sometimes, I don't know why, but you can simply right click on that and then label, like the label lower position, not in the middle. So that'll shift that, okay? Now you need to set a trend line. You can ask Excel to do that. Just right click on any of the point and say add a trend line. Now this is not helpful. It's this funny shape. So what it did is it put the linear trend line. So you want the exponential. Logarithmic doesn't work either. I tried, and exponential is the one. Now it did include the little plateau line, so that's why it looks a little too slanted, and because Excel doesn't know we're doing a growth curve where there's going to be flat lag, and then the stationary phase is going to try to include everything for the best fit curve. If you don't like, if you're not happy with that, you can delete it and put your own too. So otherwise, if you're happy, you just draw the line from here, okay? So let me take out this line and make my own line. So just delete it. And what you want to do is just the usual way, insert like using a drawing tool, just take a line and see, just eyeball it and see which one will include the most line. So that's your own trend line. Now you need to find which two numbers are double. So if you take 0.1, then your next one will be 0.2, right? So you can do that too. Draw a line, one where it intersects the 0.1, about here, stop that. And you can change the color of the line to distinguish from here and add another line. Now that one has to be 0.2. Again, see where it intersects, stop that. And then you can draw a vertical line extending up to your, it's a little bit tilted, but that's okay, you got an idea. And then another one, vertically draw down where it meets the x-axis. All right, so this interval is your that's your generation time, okay? You can also plug in the CFU per mil data. I can show you that too. Hold on a second. Okay, so now I just brought it down to make it easier. It's the same plot. I copied this set of data. We don't have 300 minutes data from the CFU per mil. So you would do the same thing. Just simply insert a scatter plot, and then as you can see, it's kind of a little flatter. It's different. Of course, it's not going to be exactly like your OT data generated graph, but that's how it looks. Now you also this is still linear, so you want to tell Excel to, oops, what happened? Right click, format axis. That's the logarithmic scale, and now it's all bunched up on the top of the graph, and that's because you have all these unwanted data too. So you can make this y-axis start from 10 to the 6 if you want, because that's your smallest number. So you put your data 10 to the 6. So that's where it will start. And yeah, so it went down. You can again do the same thing, add a trend line of your own, or make Excel pick one for you. So it depends. If you don't have any lag or stationary data, you can just choose what Excel gives. But if you have this lot of flat plateau here, then it will try to include those and you will be really skewed. So again, you can put the trend line, add a trend line, and you can select the exponential to make it straight, and the rest is as I showed earlier. So that's a very simple way of determining the generation time. So I did the same way. This is the plot for 10 to the 7 when the population reached that 10 to the 7 CFU per mil. 2 times 10 to the CFU is the double of that. So, and again, make sure you put the tick marks when you are formatting the axis so it's easier to see. And then you extend the line until it meets the slope and bring it down. So that time interval is your generation time. So you compare whether data set from data generation time generated from OD and CFU match or how off they are. They should be very close unless there was an issue with the how the experiment was done. So that's it.